This topic is about simplifying equations using the rules of logarithms. Okay, first thing I'm going to go do is go through the rules of logarithms. So log base a x times y is the same thing as log base a x plus log base a y. Okay, log base a x over y or divide by y is the same thing as log base a x take away a log base a y. I will prove these things later. Log base a x to the power of n is the same thing as n times log base a x. So the power comes down to the front to become the coefficient. Log base a using the equivalent expression means a to the power of something is equal to a, which is a to the power of 1 is equal to a. So it's always equal to 1. Log base a1 is a to the power of something is equal to 1. A to the power of 0 is equal to 1. So this is always equal to 0. Note that obviously the bases need to be the same in order to use these laws. So note the base of logarithms need to be the same to use the laws, or else you can't. Just like with the rules of indices. And I will prove this later at the end. Obviously, the proofs are not important for the course. It's just so you know where they came from. Okay, let's apply these laws to some very simple expressions. So log base 2 of 4x is the same thing as a log base 2 using the addition formula is log base 2 4 plus log base 2 of x, because 4x can be separated into 4 times x. Now log base 2 of 4 is the same thing as 2 to the power of something is equal to 4. So that must be 2. And log base 2x, because it's got unknown involved, we can't simplify anymore. So you get log base 2x. Okay. Log base 3 over x is the same thing as log base 3 of 3. Because division is the same thing as subtracting log base 3 of x. Okay, log base 3 of 3 is the same thing as 3 to the power of something is equal to 3, which is just 1. And the second term has an unknown, so it just simplifies to log base. So it's stay the same. Okay, next one, the log base 10x squared is the same thing as using the third law, which means a 2 comes down, so you get 2 log base 10 of x. Again, it's got an unknown, so we can't simplify any further. Okay, log base 10 of 10x is the same thing as separating it out because it's 10 times x. It's the same thing as log base 10 plus log base 10 x. Log base 10 of 10 is the same thing as 10 to the power of something gives you 10, which is 1. And the second term stays the same. It's got unknown. The last one is the same thing as log base 10 because dividing is the same thing as log base 10, 1, take away log base 10 of x. 10 to the power of something is equal to 1. 10 to the power of 0 is equal to 1. So this is equal to 0 minus log 10 to the power of x, which is just negative log base 10x. Okay, another way to do this one, or you could have done it equivalently as log base 10 of 1 over x is the same thing as log base 10 of x to the power of minus 1. Now using the third law, the minus 1 comes down, so you get minus log 10, log base 10x. Same answer, two different approaches. Okay, let's look at simplifying as a single logarithm. Let's call this a, let's call this b, let's call this c. So for a, we've got log base 2 36 minus log base 2 4, which is the same thing as log base 2, because the bases are the same, of 36 divided by 4. 36 divided by 4 is just 9. And 2 to the power of something is 9, cannot be solved easily without a calculator, so you can leave it as an exact value like that. Okay, b, 3 log base 5 2 plus log base 5 10. Okay, first I know for the first term I know it's the same thing as log base 5 2 to the power of 3, so the 3 goes up to power, plus log base 5, 10. 2 cubed is just 8. The bases are the same here, so it's the same thing as 8 times 10. Log base 5, 8 times 10, which is 80. Okay, the last one is log base 10, 5 plus log base 10, 6 minus log base 10, a quarter. Okay, because it's a sum going from left to right. Addition means all the logs are the same, so I can use the laws of logs. Log base 10, addition means time, so it's 5 times 6. And subtraction means divide by a quarter. So it's the same thing as log base 10. 5 times 6 is 30. 30 divided by a quarter is the same thing as 30 times 4, which is 120. Okay, next part. Write the single logarithm and simplify your answer. So these might simplify at the end. Okay, A. Okay, log base 6, 4 plus log base 6, 9 is the same thing as log base 6, 4 times 9, which is the same thing as log base 6 of 4 times 9, which is 36. 6 to the power of something gives me 36. 6 to the power of 2 is 36, so it must be 2. B. 2 log 12, 3 plus 4 log 12, 2 is the same thing as using the index one, log 12, 3 squared plus a log 12, 2 to the power of 4. So the coefficients become the power, which is the same thing as log base 12 of 3 squared, which is 9, plus log base 12 of 2 to the power of 4, which is 16. Because the bases are the same, we can just multiply 9 times 16. So 9 times 16 gives me 144. 12 to the power of something is 144. 12 to the power of 2 is 144. So the answer must be 2. Okay, C. 2 log base 10, 2, take away a log 10, 5 plus a log 10, 8. Okay, now because we've got brackets, I'm going to deal with the bracket part first. So the first term can be written as log 10, 2 squared. Subtract, because this and the things in the bracket are both log base 10, I can multiply them together, so I get log base 10 of 5 times 8, which is 40. Now I've got log base 10, 2 squared is 4, take away log base 10, 40. Because it's subtracting and the base are the same, it's the same thing as log base 10, 4 divided by 40, which is log base 10, 1 over 10. Now 10 to the power of something gives me 1 over 10. 10 to the power of minus 1 is equal to 1 over 10, so it's going to be minus 1. Combining logs example, express 2 log A3 plus log A2 minus 2 log A6 as a single logarithm. So 2 log A3 can be written as log base A3 squared plus log base A2 minus log base A6 squared, using the third law. So I get log base A9 plus log base A2 minus log base A36. This is the same thing as, because all the logs have the same base, I can just work the sum from left to the right. It's the same thing as 9 times 2, subtract log base A36, so it's divided by 36. So I get log base A 18 over 36, which is equal to a half. A log base A half can be written as 2 to the power of minus 1. So it's minus, the minus 1 comes down, so it becomes minus 1 times log A 2. And that's as much as I can simplify that one. Okay, express log base 10, 10a squared, b to the power of half and over c to the power of 4 in terms of log base 10a, log base 10b, log base 10c. Okay, so if I write this out, I can rewrite it as log base 10 of 10, because it's 10 times a squared times b to the power of half, I can separate it as log base 10 10 plus log base 10 a squared plus log base 10 b to the power of a half. Because it's dividing by c to the power of 4, it must be subtracted by log base 10 c to the power of 4. Log base 10 10 is equal to just 1, because 10 to the power of 1 is equal to 10. The second term becomes 2 log 10a plus a half log base 10 of b minus 4 log base 10 of c. And that would be it completely simplified. Okay, solve the following equations. A and B. A, we've got 2 log 5 base 5x is equal to 1 plus log base 5 of 6. Now, because x is my input for log, x has to be greater than 0. Remember, any inputs with log has to be greater than 0. So now I start solving it. So it's just something to keep in mind in the back of your head. X has to be greater than 0. Okay, so I've got log base 5. If I apply law 3, I get x squared is equal to 1 plus log base 5, 6. If I take the log base 5, 6 to the other side, I get log base 5 x squared minus log base 5, 6 is equal to 1. Okay, because it's subtracting, I can combine them together and the base is the same. I can combine them together. I get x squared over 6 is equal to 1. Got log base 5, so I can apply 5 to the power of to both sides. So I get 5 to the power of a log base 5 x squared over 6 is equal to 5 to the power of 1. These two cancel out. So all I'm left with is x squared over 6 is equal to 5, which means x squared is equal to 30, which means x is equal to plus or minus root 30. Now, although I'm getting plus or minus 30, remember x has to be greater than 30, which implies x must be equal to root 30 as x is greater than 0. X is equal to root 30 is the answer. Okay, let's go to B now. So I've got 2 log 9 base 9 x plus 1 is equal to 2 log base 9 2x minus 3 plus 1. So we know that x plus 1, the input has to be greater than 0. So x must be greater than minus 1. And we've got 2x minus 3 as the input for the log, which means that has to be greater than 0, which means x must be greater than 3 over 2. So when you combine these two together, x must be greater than 3 over 2. Okay, so let's start solving now. So remember, when we find the solutions, when we check that they're greater than 3 over 2, if they are, then they are a solution. Okay, so the first thing I do is those 2 as a coefficient, I can put it as a power. So log base 9 x plus 1 squared is equal to log base 9 of 2x minus 3 squared plus 1. I'm going to take the log base 9, 2x minus 3 squared to the other side. So I get log base 9 of x plus 1 squared, take away log base 9 of 2x minus 3 squared is equal to 1. Now, because we're subtracting logs with the same base, it's the same thing as a log base 9 of x plus 1 squared over 2x minus 3 squared, which is equal to 1. Okay, if because we've got log base 9, we can do the inverse, which is 9 to the power of. So 9 to the power of log base 9 of x plus 1 squared over 2x minus 3 squared is equal to 9 to the power of 1. So all I'm left with is x plus 1 squared over 2x minus 3 squared is equal to 9 to the power of 1, which is 9. If I multiply both sides by 2x minus 3 squared, I get x plus 1 squared is equal to 9 times 2x minus 3 squared. Okay, If I expand out the first left-hand side, I get x squared plus 2x plus 1. If I expand 2x minus 3 squared, I get 4x squared minus 12x plus 9. Which means when I simplify a bit further, I get x squared plus 2x plus 1 is equal to 36x squared minus 108x plus 81. If I take everything on the left-hand side to the right-hand side, I get 36x squared take away x squared, which is 35x squared, minus 108x minus 2x is minus 110x. 81 take away 1 is positive 80, which is equal to 0. I can see a factor of 5 going throughout. So if I divide by 5, I get 7x squared take away 22x plus 16 is equal to 0. I can factorize this as 7x and x. I need it to multiply to give you 16, and when I expand the middle terms, I get negative 22x. If I try minus 2 here and minus 8, I get the positive 16, and I get minus 14x, take away 8x, which is negative 22x. Which means x is either equal to 8 over 7, or x is equal to 2. Now remember the condition, x has to be greater than 3 over 2. So that means x equals 8 over 7 is not a solution. So solution is x equal to 2, as we ignore x equals 8 over 7, as x is has to be greater than 3 over 2. So solution is x is equal to 2. So cross that one out. Okay, next example. Given that a log base 3x plus 1 is equal to 1 plus 2 log base 3x minus 1, show that 3x squared minus 7x plus 2 is equal to 0. So just remember that x plus 1 has to be greater than 0, and x minus 1 has to be greater than 0, which implies x must be greater than minus 1, and x has to be greater than 1, which if you put together, x has to be greater than 1. Okay, so those are the conditions that it has to satisfy. Okay, we've got log base 3 of x plus 1 is equal to 1 plus log base 3x minus 1 squared using law 3. If I take the log base 3x minus 1 squared to the other side, I get log base 3 of x plus 1 take away log base 3 times x minus 1 squared is equal to 1. Because the bases are the same, the logs, and it's a subtraction, it's the same thing as x plus 1 over x minus 1 squared, which is equal to 1. Apply 3 to the power to both sides, so 3 to the power of log base 3 of x plus 1 times x minus 1 squared is equal to 3 to the power of 1. Cancel that one out, which gives me x plus 1 over x minus 1 squared is equal to 3. If I multiply by x minus 1 squared, I get 3 times x minus 1 squared, which means x plus 1 is equal to 3 times x squared minus 2x plus 1, which if I multiply out by 3, I get 3x squared, take away 6x plus 3. If I take everything to the right-hand side, I get 3x squared minus 6x take away x gives me minus 7x. Positive 3 take away 1 gives me positive 2 is equal to 0, which is what I wanted. Hence or otherwise solve. Okay, remember these conditions that I'm talking about. X has to be greater than 1 to be a solution. So I've got to, because it says hence, I need to use what I've got already. So I've got 3x squared take away 7x plus 2 is equal to 0. If I factorize it, got 3x in one, x in the other, and I've got minus 2 here and minus 1, because I get minus 6x take away x, which is minus 7x, and minus 1 times minus 2 is positive 2, which means x is equal to a third, or x is equal to 2. Now we have to ignore x is equal to a third because x has to be greater than 1. Ignore as x has to be greater than 1. Therefore, x is equal to 2 is the solution. Okay, next question. Given that a, b are positive constants such that a is greater than b, solve the simultaneous equation. A plus b is equal to 13 and log base 6a plus log base 6b is equal to 2. Okay, so we've got a plus b is equal to 13, which implies b is equal to 13 take away a in the first equation. Second equation, I get log base 6a plus log base 6b is equal to 2, implies a log base 6a times b is equal to 2. If I apply 6 to the power to both sides, I get ab must be equal to 36. Now what I need to do is substitute b is equal to 13 minus a into ab equals 36, which implies I get 13 minus a times a is equal to 36, which means I get 13a minus a squared is equal to 36. I take everything to the right hand side, I get a squared take away 13a plus 36 equals 0. I factorize this, got a to get positive 36, I must get minus 9 here and minus 4, which means I get the minus 4a minus 9a, which is minus 13a, which implies a is equal to 4 or a is equal to 9. Now, if a is equal to 4, then b must be equal to 13 minus 4, which is b is equal to 9, or in this case, b must be equal to 13 take away 9, which means b is equal to 4. So these are the two solutions. But since we know from here a is greater than b, since a is greater than b, a must be equal to 9 and b must be equal to 4. And that would be a solution. Okay, the only thing I need to do now is prove the first three laws of logs. The first one is this one, which is log base a x times y is the same thing as log base a x plus a log base a y. Okay, so start of proof. So this is the one I'm trying to prove. So it's not part of the proof. Okay, let m be equal to log base ax and n be equal to log base a y. Then that means a to the power of m is equal to a to the power of log base a x, and a to the power of n is equal to a to the power of log base a y. That means something cancel out. A to the power of m with e to the x, and a to the power of n with e to the y. Then if we multiply x times y, also x times y will be equal to a to the power of m times a to the power of n, which using the rules of indices is the same thing as a to the power of m plus n. Therefore, x times y is equal to a to the power of m plus n. Taking log base a on both sides, what do I get? I get log base a x times y is equal to log base a to the power of m plus n. These two cancel out, which means log base a x y is equal to m plus n. But m is just a log base a x, and n is just log base a y. And that was what we were trying to prove. So as you can see, the proof does work out and you've got what you wanted. So end of proof. In a similar way, if you want to prove the other one, you've got log base a x over y is the same thing as log base a x take away log base a y. So this is what we're trying to prove now. Let m be equal to log base a x and y be equal to log base a y. Then a to the power of m is equal to a to the power of log base a x and a to the power of, oh sorry, I made a mistake here. This is supposed to be n. So let m be equal to log base a x and n be equal to log base a y. Then a to the power of m is equal to a log base a x and a to the power of n is equal to a to the power of log base a y. So remember, these two cancel out. And therefore a to the power of m is equal to x and a to the power of n is equal to y. Also, x over y is the same thing as a to the power of m divided by a to the power of n, which is equal to a to the power of m take away n. Therefore, x over y is equal to a to the power of m take away n. Taking log base a on both sides, I get log base a of x over y is equal to log base a of a to the m minus n. They cancel out, which means I get log base a x over y is equal to m take away n. But m is just log base a x and n is just log base a y. And this is what we wanted to prove at the beginning. So that is the end of the proof. The last proof I need to go through is log a x to the power of n is equal to n times log base a x. So this is the last proof. Let m be equal to log base a x. Then if I do a to the power of m must be equal to a to the power of log base a x, which implies a to the power of m is just equal to x. Also, x to the power of n will be a to the power of m to the power of n, which is just a to the power of m times n, which is a to the power of mn. Therefore, xn is equal to a to the power of a mn. Taking a log base a on both sides, I get log base a x to the power of n is equal to log base a, it's not there at the bottom, log base a of m times n. Oh, this is not right. So we're taking logs of this, which is log base a to the power of m times n, a to the power of m times n, which cancels out. So I get log base a x to the n is equal to m times n. But m is just log base a x times n, which you can rewrite by flipping it over is n times log a x, which is what we're trying to prove. So those are the three proofs. Now remember, they're not essential for the course, but it's good to know where we got those rules from.